Alright guys, so for the following problems, I want you to identify the domain and range of each and then also sketch the graph. So one thing I want you guys to make sure that you guys understand is understanding what the domain is when you're finding it. Now just a reminder, when you hear the word domain, what are things that pop in your guys' head? What is domain? The x values. That's a good way. That's a lot of people think of domain. Another word for x values are inputs. When dealing with equations, and notice that we're dealing with square root equations really, I want you to kind of think of the domain as inputs, because when I tell you, hey, find the domain, I want you to find the values that you can input into this equation. Now notice that in the past, you've usually dealt with equations that you could plug in any values that you want and nothing really mathematically incorrect happens. But now that we're doing square root functions, there is a certain something or certain kind of numbers that you cannot plug in within a square root. What I'm really trying to get at is that there are certain numbers that you cannot take the square root of. And what can you not take the square root of? Negatives. Because what happens if you try to take the square root of a negative? For example, like -1. Does there exist any number that multiplies itself to equal -1? No. Because if you think of a negative number times a negative number is going to give you a positive is going to also multiply itself to equal positive. So you cannot take the square root of a negative number. What does that have to do with the domain? Well, when you look at problems like 1 and 2, and I ask you, hey, tell me what the domain is, it is your job to analyze the equation. You'll notice that you have a square root. Notice that you have stuff in the square root. That stuff is what we like to call a radicand. And you need to be like, hey, my radicand has to be positive, because if it's not positive, it's negative. And when I take the square root of that negative, I'm going to get into some problems. I won't be able to mathematically do it, at least in the real world system. So what do we need to do? We need to take the radicand and we need to mathematically express it to only show the numbers that are positive, aka numbers that are greater than or equal to 0. Now that I know that my domain is x is greater than or equal to 0, I can kind of analyze that and know that, hey, the only values that I can plug into this equation are the x values that are greater than or equal to 0. So if I'm going to start plotting points to help me get the general shape of the graph, the first value I always want to start with is the first value of my domain, which is 0. Now, let's plug in this value. Y is equal to the square root of 0. So that means that I end up with y is equal to the square root of 0. Square root of 0 is just 0. So if my input is 0, my output is also 0. Now, let's pick another point to get the general shape of the graph. Now, let's think of something that's convenient for us. So what is something that I can easily take the square root of? 4 would be 1. What's another one? 1, 4, 9. These are what are known as perfect squares. They're called perfect squares because there exists something that multiplies itself. So when you take the square root of them, you get a number out. So these are the numbers that are a little more convenient to take the square root of. So let's plug in a 4. I'm just choosing 4 just because it feels right. It doesn't matter if you put in 1 or 9 or anything like that. If I plug in a 4, the square root of 4 is just a positive 2. So that means that my output is a 2. Now, I only want to make sure that you guys choose 2 points because we know the general shape of a graph, of at least a square root graph. Notice that that point is 0, 0. That point is 4 and 2, which is located right here. Now, just to remind you guys, do you guys know what the shape of a square root graph looks like? It is half a parabola. So it's these little kind of, I don't know any other way of describing it, but it's half a parabola. Notice if this was a parabola, it'd look like that little U. The square root function is half of it. We covered this yesterday, but again, you know the beginning. The beginning of your domain is the starting point. Whatever the next point you find can kind of help you make that general graph. So that is what my graph is going to look like. So I found the domain. I graphed my graph, my square root function, but now I need to find the range. Now, if domain is my x values, what do you think your range is? 1. So let's look at my y values. What's the very first y value that I started with? 0. And notice that as I keep going down, they're probably going to get bigger. And I can check this with my graph, because look at this graph. For what y values does this graph exist? Now notice I wrote the lowest point, a line at the lowest point. Does my graph exist above that green line or below that green line? Above. So that means that we're talking about y values. Your y values have to be greater than or equal to 0. You can see it within your table or you can see it within your graph. Cool. Alright, so I want you guys to try number 2. If you guys get done with that a little bit early, you can go ahead and try 3 and 4 in the back. And then I will help you if you need any clarification on any of these problems. Alright, so the reason why I kind of put these problems two together is to kind of remind you guys of what you need to be looking for. We have 2 square root functions that we need to graph. The first thing that we should do is always kind of try to just analyze what the domain is. And the domain are the inputs, the x values that you can input into this equation. Now keep in mind that you cannot take the square root of just anything. Everything that you take the square root of has to be positive, because if you try to take the square root of negative, you just can't do it. So what's underneath the square root? Notice that we call that the radicand. The radicand is x plus 5. In order to mathematically show that it's positive, we are going to set it greater than or equal to 0. Now remember, this is x plus 5 is greater than or equal to 0. I'm looking for the specific x's, so I'm going to solve for x. I'm going to do that by minusing 5 on both sides, so that means that x is greater than or equal to a negative 5. Now that tells me what my x values are, the values that I can plug into this equation. So let me make my table, let my first value be a negative 5. Now let me go ahead and plug it in. Negative 5 plus 5 is 0, square root of 0 is just 0. Now let's think about this. What is a pretty convenient value that I can plug in to be convenient? What's the value that I could put in there? 0? You could put in 0, but what's 0 plus 5? 5 square root of 5. Now if you have a calculator, feel free to put square root of 5, leave a couple of decimals and call it a day. Now remember, these are perfect squares. Is there anything you could add to 5 so that way it equals one of these numbers? 4, right? Because look what happens when I add a 4. What is 4 plus 5? 9. Square root of 9 is 3. So is it absolutely important that you choose these perfect squares? No. You can always use your calculator to estimate, but it's kind of nice if you get used to it, you get in that routine, and it makes it a little bit easier, so on a test you can do things a little quicker. So let's plot these. Negative 5 and 0 is right over here. 4 and 3 is going to be way over here. Now remember your general shape of a square root. It's going to be half that parabola, so make sure you have that little curve. Of course, I'm not going to be too nitpicky about it as long as I see that general curve there. Now, what I always forget is once I do my domain, I sketch my graph, I always tend to forget to also tell the reader, hey, what the range is. So let's make sure we do the range. I'm going to write it over here to the top. Again, your range is your y value, so we're talking about y's. Now, for what y values does this graph exist? Now, if this is my y-axis and I'm scanning my y's, what's the very first y that appears? 0. So that means your y has to be greater than or equal to 0, because that is where your graph exists. Now, you can also check, because remember, your first value of your domain is really where your graph starts. So you can also look at your table to get the same information. All right, so you'll notice that when we work with these two problems, there's a couple things that I want you to look at. And now I'm trying to give you guys problems to kind of show you different things. Now, there's a couple of things I want you to watch out for number 3. And one of them is when you're choosing what your domain has to be. Now, when you are figuring out your domain of any equation, you always have to look for specific functions where you can input something. So, just like the other ones, the square root function is one of those, because you can't take the square root of just anything. Now, what's underneath this square root? What is the radicand? X. Notice it is not x plus 4. It's just x. Bless you, by the way. What does this x have to be? Positive. So that means that in this situation, x has to be greater than or equal to 0. Notice that it has nothing to do with that 4, because that 4 is not underneath the radical. You have to take the radical of a positive and then add 4. You can add 4 to a positive, a negative, 0, whatever your heart desires, and you can add a 4 to it, but you can't take the radical of just anything. That's why we only set what's underneath the radical greater than or equal to 0. Now let's go ahead and do our table, because now that we know our values, we know we can start with the 0. Square root of 0 is 0, plus 4 will give you that positive 4. Now, this one's kind of nice because we're just taking the square root of x. What is a nice one that we could plug in? I'm going to just put a 4 just because it feels right. The square root of 4 is 2. 2 plus 4 is a positive 6. I have my points. Here is 0 and 4. 4 and 6 is right over here. And remember that this is the first value of my domain. So that means it's going to go out to my next value. And that's pretty much it, right? Don't forget your range, because what is your range? They are the y values. So look at where this graph starts in terms of the y's, going up and down. Where does it first start appearing? There. You can also look at your y value that you first started off with. Remember, we're talking about ranges, which is y's. Your y's have to be greater than or equal to 4. If you have your domain, you have your range, you have your sketch, you're good to go. All right, is it okay if I erase this? All right, so notice that number 4, I put a lot of busy work. And the busy work is there just to make sure that you guys get concentrated on what is important. Now, if I tell you to find the domain of this function, this is 2 times something, minus 1. You can multiply 2 times any number that you want, negative, 0, positive, doesn't matter. Same thing with the minus 1. But what I want you guys to really focus on is that square root, because you cannot take the square root of just anything. You have to take the square root of what is positive. So what's underneath that square root? X minus 2. And what is true about whatever's underneath that square root? What does it have to be? Positive, so it has to be greater than or equal to 0. Notice that the 2 and the negative 1 have nothing to do with the domain, because you can technically do those operations to any number, but you cannot take the square root of just anything. Now, this is everything that's underneath the square root, the radicand. You still have to solve for the specific value, so make sure you solve for the inequality. Notice we end up with x is greater than or equal to 2. Those are the values that you can plug in. You'll notice if you try to plug in a value that's not in the domain. So if you think of values that are not greater than or equal to 0, for instance, let's plug in a 0. 0 minus 2 is a negative 2. Can you take the square root of negative 2? No. So that is why that doesn't work out, right? So we know the first domain value could be x. Let's go ahead and plug it in. 2 minus 2 is 0. Square root of 0 is 0. Times 2 is still 0. Minus 1 is a negative 1. Now, what is the next value that I think makes sense for you guys? What else should we plug in? Anybody have any ideas? 6? All right, 6 sounds good. Because what is 6 minus 2? 4. Square root of 4 is 2. Times 2 is 4. Minus 1 is a positive 3. So you can see here that, yeah, might have took a little bit thinking, but then once you get it rolling, the math comes a little bit easier. So let's go ahead and plot these. 2 and negative 1 could be located right over here. 6 and 3 can be located right over here. Remember, the general shape of your graph is that half of that parabola. That is pretty much that. Don't forget your range, though. I like to look at my table because it just makes it a little bit easier, right? What is the first y that shows up? Negative 1. You know that that's where they're going to start, and it needs to be greater because, again, your graphs exist above. You can see that the y values would get bigger and bigger as you plug in bigger values. And that's it. Anybody have any questions? No?